Hello everyone, I am Aishwarya, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to see a topic, diagrammatic representation of data. So graph which consider the frequencies for the presentation of data are called frequency graphs. These graphs are used to describe the characteristic feature of the frequency data. The methods for the preparation of the frequency table is already discussed in the previous module. The frequency graphs usually depends on the type of data, whether it is discrete or continuous. Discrete data are usually represented in the form of bar diagrams or discontinuous curves, while the continuous data are represented by means of curves. While constructing the frequency graphs, usually the value of the variables are taken on the x-axis and the corresponding frequencies are represented on y-axis. The graphs that are used for this purposes are histogram, frequency polygon, and O-gives. First one is histogram. It is among the most commonly used method for the diagrammatic representation of the group frequency distribution. On one axis, it consists of bars with the height proportional to the class frequencies, and the width of the bar is defined for the class boundaries presented on the horizontal scale. In general, same width is considered for all bars, but it is not essential as it depends on the class width. In histogram, there is difference in terms of height only due to the class frequencies. The area of each bar is calculated by multiplying the width of the class and the frequency. So next one is the diagrammatic representation of data. Suppose we are interested to compare the marks of your mates in a test. How can you make the comparison interesting? It can be done by the diagrammatic representation of the data. You can use a bar diagram, histograms, pie charts, etc. for this. You will be able to answer questions like how will you find out the number of students in various categories of marks in a certain test? What can you say about the marks obtained by the maximum students? Also, how can you compare the marks of your classmates in 5 other tests? Is it possible for you to remember the marks of each and every student in all subjects? No. Also, you don't have time to compare the marks of every student. Merely noting down the marks and doing comparison is not interesting at all. So the graph representation is a way of analyzing numerical data. It exhibits a relation between data, ideas, information and concepts in the diagram. It is easy to understand and it is one of the most important learning strategies. It always depends on the type of information in a particular domain. There are different types of graphical representation. Some of them are as follows. The first one is line graph. Line graph or the linear graph is used to display the continuous data and it is useful for predicting future events over time. And the next one is bar graph. Bar graph is used to display the category of data and it compares the data using solid bars to represent the quantities. And the next one is histograms, the graph that uses bars to represent frequency of numerical data that are organized into intervals. Since all the intervals are equal and continuous, all the bars have same width. Next one is line plot. It shows the frequency of data on a given number line. X is placed above number line each time when the data occurs again. So next one is frequency table. The table shows the number of pieces of data that falls within the given interval. So the last one is circle graph, also known as the pie chart, that shows the relationship of the part of the whole. The circle is considered with 100% and the categories occupied is represent with that specific percentage like 15%, 56%, etc. So first we are going to see a bar graph. The pictorial representation of group data in the form of vertical or horizontal rectangular bars where the length of the bars are equivalent to the measure of the data are known as bar graphs or bar charts. The bars drawn are of uniform width and the variable quantity is represented to one of the axes. Also, the measure of the variable is depicted on the other axis. The height or the length of the bars denote the value of the variable and these graphs are also used to compare certain quantities. The frequency distribution tables can be easily represented using bar charts which simplify the calculation and understanding of data. The three major attributes of bar graphs are the bar graph helps to compare the different sets of data among different groups easily. It shows the relationship using two axes in which the categories are on one axis and the discrete values are on other axis. The graph shows the major changes in data over time. So we are going to see an example. In a firm of 400 employees, the percentage of monthly salary saved by each employee is given in the following table. So represent it through a bar graph. Here the following data are given. So we have to represent this data in a bar diagram. So here I'm taking saving as an x-axis and number of employee as an y-axis. So using the given data, I draw a graph which is a bar diagram. So the next one is a cosmetic company manufactured four different shades of lipstick. The sale for 6 months is shown in the table represented using bar charts. So same we are going to use a bar chart for this data also. Here the month and sales are given in the data format. So we are going to represent these data in a bar charts. So the month is taken in an x-axis and the sales is taken in an y-axis. So the given data are marked in that chart using the bar diagrams. The next one is pie chart. The pie chart is also known as a circle chart, dividing the circular statistical graphic into sectors or sections to illustrate the numerical problems. Each sector denotes a proportionate part of the whole. To find out the comparison of something, pie chart was the best at that time. In most cases, pie chart replaces other graphs like the bar graph, line plots, histograms, etc. The formula for the pie chart is given data by total value of data into 360 degree. So this is the steps to create a pie chart. So first we are going to take a survey. So imagine a teacher survey her class on the basis of favorite sports of students. The data above can be represented by a pie chart as following, and by using the circle graph formula, the pie chart formula given below. It makes the size of the portion easy to understand. So first enter the data into the table. So the given data are entered in the table, and the next step is add all the values in the table to get the total. So here the total students are 40 in this case. So next we have to divide each value by the total and multiply by 100 to get a percent. So we are dividing each term by 40 and multiplied it by 100 to get the percentage value. And the next to know how many degrees for each pi sector we need, we will take a full circle of 360 degree and follow the calculation below. So the formula is central angle of each component is equal to value of each component divided by sum of values of all the components into 360 degree. So the same will be the values will be divided by 40 and it will be multiplied by 360 degree. So we get the values as in the form of degree. So now we are able to draw a pie chart for these values. So using the find out values, I draw a circle and use the protractor to measure the degree of each sector. So this is the pie chart we obtained for the given data. So the next one is histogram. Histogram is a graphical representation of a group frequency distribution with continuous classes. It is an area diagram and can be defined as a set of rectangles with bases along with the intervals between class boundaries and with areas proportional to frequencies in the corresponding classes. In such representations, all the rectangles are adjacent since the base covers the intervals between class boundaries. The heights of rectangles are proportional to corresponding frequencies of similar classes and for different classes. The heights will be proportional to corresponding frequency densities. In other words, a histogram is a diagram involving rectangles whose area is proportional to the frequency of a variable and width is equal to the class interval. So the histogram graph is used under certain conditions. They are the data should be numerical. A histogram is used to check the shape of the data distribution, used to check whether the process changes from one period to another, used to determine whether the output is different when it involves two or more processes, used to analyze whether the given process meets the customer requirements. So this is the difference between the bar graph and the histogram. So histogram has a two-dimensional figure and the bar diagram has one-dimensional figure. So histogram is shown by the area of each rectangle. The height shows the frequency and the width has no significance. For histogram, it shows rectangles touching each other. For bar diagram, it consists of rectangles separated from each other with equal spaces. So the first example is the following table gives the lifetime of 400 neon lamps. Draw the histogram for the below data. So here the lifetime of neon lamp is given in the table. So we have to draw a histogram for the given data. So here the x-axis taken as lifetime and the number of lamps will be taken as an y-axis. So using the given diagram, I draw a histogram for this data. The next one is frequency polygon. A frequency polygon is a line graph of frequency class frequency plotted against class midpoint. It is almost identical to a histogram, which is of data or to display a cumulative frequency distribution. It uses a line graph to represent quantitative data. To draw frequency polygon, first we need to draw a histogram and then follow the below steps. Choose the class interval and use to compare the certain marks the values on the horizontal axis. Mark the mid values of each interval on the horizontal axis. Mark the frequency of the class on the vertical axis. Corresponding to the frequency of each class interval, mark a point in the height in the middle of the class interval. Connect these points using the line segment. The obtained representation is a frequency polygon. So this is the example of a frequency polygon graph. So thus a frequency polygon in a line graph of a class frequency plotted against class midpoint. Thank you.